In this presentation our API pilot project Transport Track and Trace. First, a few remarks on the background. In 2020, VDA and ODEC jointly launched a project to investigate the potential of REST API in data exchange in the automotive industry. The goals were in particular to familiarize themselves with the technology, to find out which standards exist and can be used, identify potential use cases. We don't want to simply replace the existing systems with another technology. That would be useless. We want to improve transparency in the processes between suppliers, transport service providers and their customers, and find new ways of creating a digital image of the processes to complement existing solutions. One use case, a business case, that we have identified is as follows. Delivery advice notes are usually exchanged between suppliers and their customers, in which the information on the parts contained in a shipment is also transferred. Ideally, information is also provided on which means of transportation this shipment was loaded onto. The customer, the recipient of the goods, then has the relevant information. However, it is often the case that this information is either missing or incorrect. At the same time, we have developed a sophisticated system for tracking means of transport in the past, and many partners have implemented it. The customer therefore knows which trucks are on their way to their plants. However, if there is no information about which truck is carrying which shipment, then it is of course very difficult for the customer to assess whether delays in the transportation process are critical or whether they are tolerable. And if they are critical, what measures can be taken to counteract them? We then defined a process on this basis and implemented it in our T3 MWP, which I would now like to briefly present. On the one hand, system, which is actually the central system, and the core of the T3 application. The backend system is the API provider, i.e. it provides the API interface for other partners. It has a database in which the events and information about the shipment and the transportation process are stored. Then we have the partners involved in the transport chain, i.e. the shipper, forwarder or carrier, cross-dock, possibly another forwarder or carrier, and of course, the recipient of the goods. These are the API consumers, i.e. the users of the API interface, who provide data via this interface or receive data on their devices via the interface. Ideally, of course, mobile devices are used, especially in the core of the process, in the transportation process. There, the drivers use mobile apps, possibly also in the cross-dock, and of course, mobile devices can also be used by the consignor and the consignee, for example at the loading ramp or the unloading ramp. However, the information could of course also be fed into the backend system from the existing stationary system or pulled from the backend system. We have initially defined 9 events. It starts with the message that a shipment is ready for pickup, which can be sent to the backend via the IP. If the supplier loads the goods himself, which happens in many cases, then the supplier can also report that he has loaded the goods onto a specific means of transport. That is the core of the matter, that you then marry the shipment and the means of transportation. Whether the forwarder or carrier loads the goods themselves, they can of course also send the relevant information. The same applies to the recipient of the transport section when the shipment has been unloaded. The recipient, in this case the cross-dock, can send this message. The cross-dock can also send the message that the consignment has been loaded onto the next means of transport. Alternatively, the forwarder can do this again. The same applies to the unloading process. Many customers also unload themselves and do not let the drivers get out of the vehicle at their plants. Finally, you can also report the completeness of the consignment in the incoming goods department in this way. At the moment, the reports always refer to the complete consignment. But in the next expansion stage, it should also be possible to report deviations, damage, losses and the like in order to have a precise overview of the transportation process. The whole thing is realized via a REST interface per transport event. All information would be stored as an event in the backend. And this results in this digital transport file at the end. On the one hand, we have all the recorded events here, including the information about who recorded the event. In this case, for example, the consignor who also loaded the goods. This is a direct relation. The unloading was carried out by the consignee. You can see here that during loading, the consignment number that we see above is linked to the specific means of transport. Accordingly, the consignee or the consignor can also see the progress of the shipment by entering this means of transport. We have also stored the detailed information for the shipment in the system, i.e. the most important details with the IDs of the consignor and consignee, the current status, the number of loading units here and the numbers of the individual loading units, i.e. global, unique numbers, the license plates and corresponding shipment-related information. The date of dispatch. The expected date of arrival at the consignee. When the shipment was created. When it was last updated. You can also use show this event was recorded, so that you really do get a complete digital transport file that is available to the consignor and consignee. This can also be used for billing processes. But probably the most important case is being able to take appropriate countermeasures quickly in crisis situations. Larger amounts of data can then also be used to analyze whether the assumptions about how transports should proceed are realistic or whether adjustments need to be made. That is the theory, that is the intention, and in the second part of the presentation I will show how we have implemented this in the system at the moment. As I said, we are testing mobile apps used in the transportation industry to integrate support for this process into their systems. But so that we don't have to wait for the software vendors and can start testing and piloting in the already, we have developed a small app ourselves that supports this core functionality. Here with TeamViewer, I'm looking at a mobile device. There I start the application once, so we have our client app here. That's where I have to log in first. I hope that works here. Then the authorization system requires that I allow this app to access the data in the backend. After confirming, this screen appears here. First I select my role. So I can say I am supplier, I am cartier or forwarder, customer, consignee, or cross-dock. In this case, I've logged in as ship from, which is the goods shipper. Then I see the two functions that are available to me here. Ready for pickup and issue completed. It looks similar with the carrier. Pickup completed and proof of delivery completed, i.e. the message that the carrier has unloaded. I can also start my tour here. As ship to, I can then say I have unloaded the shipment and performed goods receipt. In the cross-dock there is unloaded and loaded. We then have other settings so I can test certain functions. If the app is also used to trace the means of transport, then I can also set the interval here and of course set whether I want to have German or English in the user guidance. I can log out again here. Now let's go back here to the first screen. So I say I am goods shipper and I want to tell the system now that I am ready for pickup. Now I need to use times second screen, so I press ready for pickup and then the system tells me to scan the appropriate shipment code. Now the app has scanned that and I can transfer that to the backend system. I get a success message. If I go into the backend system and search for the shipments here in the menu, I actually see here now, the shipment has been created and I can see here that the status has been set as ready for pickup. I can see here, there are 20 loading units and here are the numbers of the loading units. The next step would then be that I say, the shipment has been loaded. Again, we have developed a special a tour label that contains the necessary information. Shipment date. More important, license plate number of the truck. Who is the carrier? Who is the forwarder? Then there is a tour label, in this case Tour 1. The whole thing is contained in this little data matrix code. Then if I want to say I've loaded a shipment, I have to scan this code. We'll do that again. Hold on, I'm going to switch back to TeamViewer. So we go back here, and I now say I've loaded the shipment, issue completed, and the first thing I have to do is scan the new label. I've done that, and then the second thing I have to do is scan the shipment receipt again. Here it is now completely sufficient to scan the small code. I transfer the whole thing and get a success message again. When I then look here in the backend system, I see the result. I have obviously pressed commit twice now. I see here in the events that the shipment has actually been loaded. This is how it continues in the individual stations until I have the complete transport file. The bottom line is that I can understand. When did the supplier report readiness for shipment? When was it picked up? How did the transport process proceed? And so I have my detail. Both the consignor and the consignee have access to all the information. The service providers involved only have access to the part of the information that they themselves have supplied. So if they themselves have loaded, if they themselves have unloaded, then they can see that. Goods shipper and recipient, as said, could see the entire file, and thus one has a much greater transparency. The consignee can now also see here, and this is the goal, what the status is, especially for critical parts. He can see the current status and the position of the corresponding message at any time, which means that it is possible to assess whether the expected arrival date will be met or whether there will be a delay in the planned process, and whether this delay will affect the production plan or whether any special measures will have to be taken or similar. This is basically the summary of our current application. Of course, we also have complete user management and company management here. We also have a strict separation between the individual areas, so everyone can really only see what concerns them themselves, but that may be a bit too far in the context of this introduction here. Now we are organizing a pilot with interested and willing partners to find out. How manageable is that in the practical process? Does the interface and do the tools that we have generated meet the expectations? Can it be used well in the daily process? There are certainly always enhancements and improvements that can be made in order to ultimately turn this into a productive system. Maybe as a small addition. For those who cannot use the TSB generator from Volkswagen, we have developed these tools. You can generate the XML file with the shipment data. If you enter the essential parameters here, which I have shown earlier, then you can generate an XML file, and in the next step you can generate the data matrix code of the shipment by selecting the XML file here, and then in the corresponding shipment document can be generated. And with that I would like to end my presentation now.